up there. So, you guys will, if you don't want to ask a question or you don't think of it till later on, you're having dinner tonight or you're laying in bed, you're like, I wish I would have asked that question. The contacts, you can reach out to us and ask those questions. But I'm going to go ahead and send a chat to everybody right now, just so you can see where the chat is. Now there is a drop down, so you can choose who you want to ask that question to. If you can just make sure that everyone or my name or all panelists, if the word all is in it, I'll receive it. And then I'm the host, Caleb Powell, so you can just choose just to me if you don't want everyone to see your question. But just make sure the word all or all panelists, host, or just my specific name is chosen so that I can see that and I can ask that to our speaker. So just to give an overview of what's going to be covered today, we are going to be talking about energy assessments, what we see the most, and then why that matters. So we've got an expert-led session today on top energy waste issues uncovered during industrial assessments. We're going to be discovering practical solutions from quick fixes to long-term strategies. And this can help you reduce costs, improve efficiency, and then also maximize performance at your facility. So I am going to pass it on over to Dr. Jeff Marchetta. He is professor and the undergraduate program coordinator in mechanical engineering at the University of Memphis. He's also the University of Memphis's director for the Industrial Training and Assessment Center. You guys added training, so I'm used to it being the IAC, but now it's ITAC. So had to learn that. But without further ado, I'm going to pass it on over to Dr. Marchetta, and the floor is yours.
All right, thank you, Caleb. I appreciate the warm introduction. I'm happy to be here today and take the opportunity to really kind of go over some I think low-hanging fruit for most companies, very low capital intensive types of things that you can do quickly and save energy quickly and save money quickly for your facility. I don't see the presentation. There it is. Okay. So as Caleb said, I am the director of our Industrial Training and Assessment Center here at the University of Memphis. I'll talk more about the ITAC and currently a professor of mechanical engineering. So our mission was essentially established way back in 1976 by the Department of Energy. And the goal was twofold. Number one, to provide no-cost energy efficiency and productivity assessments to SMMs, or small and medium-sized manufacturers. So if I say SMM, that's what I'm referring to. Our assessments are typically classified, if you're familiar, as an ASHRAE Level 2 assessment. So there's essentially 3 levels of ASHRAE assessments. So this one kind of puts you right in the middle. The highest level is definitely leans more on the implementation side, and usually requires a much more detailed study of the facility or the system over, could be months or even a full year. Whereas our assessments are typically one-day assessments. The other prong of this program, equally important, is that we provide hands-on training to students. And this is important. I mean, this is really one of the very early workforce development grants issued by the federal government. And the goal, of course, is to grow clean energy and manufacturing jobs, but also to help plants with productivity and cost savings. And also, the students are really in demand. I mean, facilities, even though the mechanical engineering student or the electrical engineering student is in a facility doing mechanical engineering or electrical engineering functions, having this knowledge and awareness really helps them to work effectively with the other people in the plant, the environmental safety folks that are trying to also focus in on energy efficiency and safety. Next slide. So the University of Memphis works in a partnership with Tennessee Tech University, and we call our kind of partnership a 3-star ITAC program for the state of Tennessee. But it also covers other areas that surround the state. So, for example, Tennessee Tech covers parts of Kentucky, Virginia, West Virginia, North Carolina, and I cover parts of northern Mississippi and eastern Arkansas out of the University of Memphis site. So we're not just strictly limited to Tennessee, and we do provide important coverage to those areas that are peripheral to the state. So collectively, we've performed over 350 assessments since we started our center here in the state in 2006. So we are, I would say, fairly experienced, and we were designated by the Department of Energy in 2018 as the best ITAC center in the country. So we're really proud of that award. And we also partner with TVA and TDEC. I get the privilege to work with people like Crystal and Caleb as we work together in our visits and site assessments. We also work with TVA and some of their contractors so we can identify energy rebate opportunities. So it is a very much a collaboration. Next slide. So this is just kind of a map. As I said, this is a program that's nationwide. And I think we have right now about 30 centers nationwide. And so you can see we pretty much cover the geographic map here in the States. So if you're, wherever you're located, there is going to be a center close enough to you to get an assessment if you want one. Some of our statistics, we have 252 students that have been trained through the program. These are students that have actually participated in at least 6 assessments, and they've earned their certificate. We've assessed, as I said, roughly 350 plants. We've identified 124 million in energy cost savings. And then, 14 trillion BTUs for you energy wonks out there and energy savings. So the impact of this program is widespread, and it's been fairly significant. Next slide. So some of the things that we focus on, essentially, I'd like to say that if it consumes energy, it's fair game for us. So we have the expertise to look at compressed air system, motors, pumps, lighting, boilers, steam systems, heating and cooling, HVAC air handling, and renewable energy. All of those are systems that we can look at, and we even dive into specialized systems that might be unique to a particular industry if we feel like there's an opportunity there. We also address in the plant productivity issues. So if we see bottlenecks, we can do limited time studies in the plant to see if we can identify any areas where the plant could improve in its productivity. And also we do work closely with TDEC to identify waste minimization. So I do rely on their expertise in-house, particularly on looking for solutions for wastewater and recycling programs. And I found that to be very informative for the plants as well, that we can include that information. Next slide. So the eligibility requirements for a no-cost assessment out of our center, you have to be in the manufacturing NAICS classification range, 31 to 33, that's the 6-digit number. We will do some agricultural production, like, if you're growing crops or raising cattle, they consider that production, and we can do those as well. And also we have done some mining assessments as well, as long as it's a production type of mining facility, like mining ores, natural gas, or even sand. And again, I mentioned, I say roughly 150 miles of an IAC. I've driven further. For me here in Memphis, I'll drive to Little Rock, I'll drive to Nashville, I'll drive to Jackson. That's probably about the bounds of what we'll assess. And anything outside of that, if you're, on the other side of the state, then Tennessee Tech would handle those out of their center. Gross annual sales less than 250 million. This is the site. So if you're a conglomerate that has multiple sites, we're not asking for that number for the entire organization, just looking for an estimate of the sales out of that particular facility. Less than 500 employees, and then annual utility bills that range between 100,000 and 2.5 million. And then they asked that this be done for facilities that don't really have experts that can perform these assessments themselves, which, there are several large manufacturing facilities. I think of automakers, for example, where they actually do have energy efficiency engineers in full-time positions to be able to do these assessments themselves and go to training. Next slide. So some of the information that we need prior to the assessment, we do need 12 consecutive months of your utility bills. That's electric, gas, water, and sewer. We also ask you to complete a pre-questionnaire, which you can see a little excerpt of that over to the side there. We understand that you may not know all of that information, and that's okay. We just ask that you do the best that you can so that we can use that document to kind of plan our assessment before we land on site. Even if it's something as simple, hey, we have 2 compressors, we have no idea what the horsepower is, that's fine. We can come in and get that information, but it does help us, plan on what equipment we need and what areas we might want to focus on. And then finally, we need a plant map. This is just, this could be even a fire emergency map, something that kind of gives us ability to orient ourselves when we're in the plant, but also maybe mark specific locations where we found an opportunity so the plant people can go back and identify that site. Next slide. So during the on-site assessment, again, these are typically 1 day. They can be 2 days, depending on what the assessment requires. And the size of the facility. But we usually start the day with a kickoff meeting. Then we go on a short tour just to orient ourselves. So it's not necessarily the same kind of tour you might give to somebody that wants to know every single detail about how you're manufacturing a metal component. And then a strategic team meeting where we kind of say, okay, this is what we observed. This is what we got out the pre-questionnaire. Now we need to kind of get together and decide what data do we need to go out and collect. We bring our equipment, set up our loggers so that we can begin our data collection. And then by the end of the day, we typically have a fairly good idea of the recommendations or opportunities that we think we want to pursue. Now, what that means is we're going to go back and then we're going to do the calculations and see if there's reasonable paybacks, look at the capital costs of the investment. But this gives the plant people the plant personnel a good idea of what they can expect in the final report before we leave. So it's not kind of a black hole to them. I've also included some pictures of some things we've seen on previous assessments. So if you're wondering why there's a wrench over there attached to a safety valve, that's some of the things that we do identify. This particular plant, they had this set up with this wrench on the safety valve, and unfortunately, when the safety valve was needed to activate and the wrench was holding it in place, they destroyed a $2 billion CHP system, combined heat and power system. So, I circle some of these things as kind of like, worst case scenarios, but typically we don't see this. This is a rare exception, but I just put that there to kind of show you, like, we see a lot of things. Next slide. Over here, so after the assessment, we of course collect data, we'll bring it back, do calculations. We give you all of those calculations, whether you want them or not, but it will include an executive summary if you don't want to see all the details. You will get an estimate of what the cost and energy savings are, as well as what the payback is, or our best guess at that, and implementation information. So and that that'll be summarized as well as detailed in the report. If you're concerned about this information being in the public domain, of course we do and will keep your information confidential. Excuse me. We do submit the information into our ITAC database, but it doesn't have any identifying information where somebody could say, oh, this was performed at plant X. We can secure your confidentiality if there's an issue there. In most cases, it's not, but we can do that. We also have non-disclosure waivers by all of our students and faculty that participate in the program. And we can also, if your company requires a specific NDA or CA, we can also do those as well. And then there's a follow-up report that you will get. That report I talked about, you're going to get that between 6 and 9 months after the on-site assessment. Okay, so let's start with first number one. This is kind of my David Letterman countdown here. Most common assessment opportunity that we see when we visit plants. And this one is really simple. It's turning off equipment when it's not being used. Sounds easy, right? This is things that are typically idle, right? Motors, compressors, pumps, when you're not actually in a production mode for the facility. A lot of times you'll think, oh, the equipment is in idle, but keep in mind, in many cases, this equipment is still consuming energy. And in some cases, it can draw between 5 and 50%, as you can see there, of full load power, depending on what it is. And so simply turning it off, I mean, it's going to be a very small payback, even if you incorporate automation to if you're concerned about putting the weight or burden on an employee to actually flip a switch, that's understandable. One way to do that, of course, is to include automation, and we'll talk about some of those strategies in a second. But if you look in that picture over to the right, this is a great example. I mean, it's a facility that mostly has robots in it. And what you won't see in that picture is people. And what's interesting about that is the first thing I look at when I see that is, oh, that's really great. There's a lot of automation in the robots, but then the lights are on. Well, robots don't really need lights to operate. There's a lot of plants that have started to make an investment in autonomous guided vehicles or forklifts in their plant. AGVs, they are expensive. They're upfront. The upfront capital cost is pretty significant. But then I've walked into the plant, I've seen these autonomous forklifts in a warehouse, and there's nobody in the warehouse, and the lights are on. So again, it's funny, but at the same time, when you're in the plant, you're not thinking about that. I understand that the people on the floor in the plant, they're not really thinking about the lights being on, and they may also be concerned about safety. What happens if I turn the lights on and somebody enters the room? That could be an OSHA thing. Well, it turns out there are strategies that you can use so that you can avoid that liability or safety concern that you might have by having the lights out in that situation. Next slide. So these are numbers from some of our assessments that show you some of the savings that we've estimated when simply turning machines off. Here's a manufacturer we visited. This plant had a lot of exhaust fans, and they were, operating roughly 5 days a week. We'll say 24 hours a day, but then the exhaust fans were left on all the weekend long, right? And so this is literally how much they could save if they just turn the exhaust fans off in the plant, right? And in this particular case, it was a fairly large plant. It was, a large, medium-sized plant by our definition, which is why that number is large. But again, when you see a number like that, it's pretty significant. And we had implementation strategies which allowed us to see payback periods of 1 month to save that cost. Other applications we've seen here, you can see dust collectors. Those are frequently left on when we go into plants. What perhaps the part of the operation that needs the dust collector is only operating through half the production day. Maybe it's a piece of their overall production process, and then they just leave the dust collector running for the remaining period. So you can see the payback on that. Welders is another opportunity. Just because you're not using the welder, these welders still consume energy even when they're idling. So a final example, air compressors are one of the most costliest pieces of industrial equipment in a plant in terms of both the cost to purchase, but also the cost to operate. And we'll talk about that also as well in a minute. But here, again, this is literally from one day in a small plant of leaving the compressor on over the weekend and not turning it off. $6,000. So we can find an automation strategy if it's needed, if you're concerned about relying on a maintenance person to actually turn the compressor off, which is a valid concern.
Hey Jeff, I had a question here. So
Yeah.
when the payback period, so what's the investment for these that you guys offer up? Is it like the automation that you were talking about, or because I was trying
Yeah,
to think about, yeah, what is,
implementation. So
yeah.
for the fans, for example, we're able to tie that into the building management system. So, you can see, right. I mean, I could have put the implementation cost in there, but if the cost savings are 76,000 and the payback period is 1 month, the implementation cost is essentially less than $1,000. So, um, in some of these situations, occupancy sensors, you need more of those. You don't necessarily have to put those, for example, on every fixture there, because fixtures are usually tied together in groups of like 8 or 10. So what you do is you put the occupancy sensor on the fixture group, right? But you do need more of those, and they cost a little bit more, which is why that payback period's a little bit higher. But so, that brings us exactly to lighting. So on this slide, you know, lights are easy for the most part. Nowadays, most everybody has LED lights installed in their plants. It took us roughly 25 years to move that initiative forward. I don't go in and see a lot of fluorescent lighting anymore, which is good. But the opportunities are still there for occupancy sensors. And the concern that I often hear from plant people is, well, I don't want the occupancy sensor to go off if somebody's not in the space for 2 minutes. Well, that's true. You don't. In most of these case studies that I have here, these were situations where um, the plant would maybe operate for 18 hours a day, and then they just simply wouldn't turn the lights off for the rest of the time when they weren't in production and there wasn't anybody in the facility. So we're not talking about these things turning on and off, when somebody's not in the space for 15 minutes. You put these on longer timers, and you do that when you're going to have potentially a significant window where nobody's going to be in the plant, so that you don't have to rely on somebody for those, because again, they're fairly inexpensive to implement as far as energy saving measures go. So you can see some of the paybacks there: 44 months, 7 months, 22 months, 10 months. Those numbers really depend on the facility, so that's why you see that variation. But we see a lot of opportunities there. Here you see in the picture there on that slide, again, the robots, but here we have the lights turned out, right? So this is a good implementation of not having the lights on when nobody's home. So next slide. So again, implementation strategies. I've already talked about occupancy sensors for lighting, but for other things, if you're operating a production line and you're relying on the operator to turn the equipment off when they go on their lunch break, right? There's ways that you can do that. You can use pressure plates. You can use badge and key activations that requires them to take an action in order to operate the equipment, so that if they're not in the location, they don't have the badge there for the equipment to be on. We can also integrate things into the building automation systems if they have those. And if you don't have those are definitely worth exploring. They are expensive to implement, and they're not the right fit for everybody. But you can integrate some of these technologies into those types of systems if you've got them. PLCs is an example for conveyor systems, or batch production lines. Laser brake sensors are used frequently, especially if you have long periods or gaps between products. You don't necessarily need your drying fan on if you're have no product there for 10 minutes, right? So you can have a brake that turns your drying fan off and then back on when product is detected. So these are some of those strategies. In most cases, again, the implementations, other than the building automation system, most of these implementations are fairly inexpensive to put into practice. So the next one that we see often are compressed air leaks. I'm sure if you're in a plant that has a compressor, the telltale hiss of a compressed air leak, and you may feel, that it's futile, right, to continue. If you were to continuously fix all of these leaks, you would never do anything else. And I can understand that feeling of like, I'm never going to win this battle. The battle is not to necessarily fix 100% of your leaks. The battle is about finding the ones that are costing you the most money and trying to get your leak load down to a reasonable number. So starting this is, you have to understand compressed air is roughly 10 times more expensive than just using the electricity directly for mechanical load. So it's a precious and expensive commodity, and we're not saying you shouldn't use it. We're just saying that you should use it when it's really needed, and that you need to take the steps to maintain that system to avoid leaks. So here's some examples of some of the costs. Given the assumptions that we're operating at 100 psi pressure, which most compressors that I see in small and medium manufacturers are operating between 100 and 125 psi, typically rotary screw. Compressor efficiency 20 kilowatts per 100 CFM. That's fairly standard for a modern compressor. But long story short, if you're factoring in an electricity rate of, say, 10 cents per kilowatt hour, you can see that a 1/2 inch hole, under those assumptions, is an $18,000 leak, right? And, if you have 10, holes that are 1/8 inch, you can then multiply that number of $876 by 10, and then that starts to become a big number. And a 1/8 of an inch is not that big of a hole, really, when you get down to it. This is essentially a little bit bigger than a pin-size hole. So when you hear these hisses, those are the ones that you should fix, because if you hear it, that means it's got decibels in the audible range. There are probably a lot more leaks that you can't hear. So if you can hear it, that should be very high on your list for repair. Okay, we'll talk about how you find the ones that are more difficult to hear, and some of them are simply difficult to hear because you're in an environment, in a plant that might be producing that's the noise is overshadowing the noise of the hissing that's coming from the line itself. So our assessment data has been showing for plants typically between leak rates of between 10 and 40% of the compressor output. Now, think about that. Your compressed air is making so many cubic feet per minute. Well, in order to make that cubic feet per minute, only a little less than half of that is actually being used for its intended purpose, if you're at 40%. And I'll tell you that we tend to see leak rates at the plants we visit that are usually between 20 and 40. I rarely see 10% leak rates. They're usually between 20 and 40% of the compressor output. So we, recognizing that a 0% leak rate is impossible to achieve. I mean, essentially, as I mentioned, you will feel like you're on a gerbil wheel if you try to chase every single leak till you get down to zero. The idea is to try to get your leak rate down to 10%. And we know that because that's our best energy efficiency plants in the country, the ones that, we've measured and looked at and are rated by DOE as a better plant. They're able to achieve 10% leak rates in a reasonable way with reasonable strategies to get that leak rate to that level. So what we usually propose is that you try to get your leak rate down from, let's say, 30% down to roughly 10%. Again, payback periods for this are typically less than 1 month, and I'll show you that why in a second. Here you can see a picture of a regulator. Regulators are almost always a source of compressed air leaks, just because that's where a lot of fittings and connections are made in the compressed air line. So we see that a lot, and we get a lot of hits around those regulators. Next slide. So again, this shows you some of those costs. Column 1 there, again, these are directly from out of our assessment center here. We can see the annual compressor costs in that first column there, and some of the cost savings that we've identified in some of these facilities. I mean, look at number 1. The cost to run the compressor is $64,000. The cost savings to go from 48% down to 10 or 15% is roughly $26,000. Yeah, that's a significant amount of money, right? I think that's worth, you could almost pay somebody $15 an hour and have them come into the plant and do nothing but identify and repair leaks, and recover that cost in 1 year. So, I hope this reflects the values of really taking the time in your plant to find these leaks, particularly the bigger ones, particularly the ones that you can hear hissing on a production day. Those are the ones that are costing you the most money. And I'll also add on, you should think about how you're using the compressed air. If you're walking around your facility and people are blowing their boots off with a compressed air line, remember what I said earlier about the cost of compressed air. Is there another way to remove the dust off the boots? Well, if you're a smart manufacturer, you use vacuums. One of the other reasons, aside from using compressed air, which is expensive, is it's also a safety issue. If you're blowing dust into the air, that potentially could get into somebody's eye, right? So now this becomes an EH&S issue. So think about ways, particularly when you're blowing in the production process, or you're using compressed air outside of the production process for something like blowing dust or cleaning equipment, whether there's an alternative that's both less expensive and safe. Next slide. So what do we recommend? We recommend a leak detection and repair program. What is the implementation? Well, if you look over in that picture, you'll see that little purple handheld device. That is what we use. That costs roughly $7,000. Just purchased one last year as a replacement. You can get an ultrasonic leak detector for as little as $1,500, or something a little bit more expensive like this for $7,000. So I just showed you the paybacks and savings in the previous slide, and you can see even if I spent $7,000 in one of those plants, my payback is still less than 1 year on purchasing that device and identifying the leaks. So what we recommend is that you baseline your performance, establish what your leak load is now. We can do that during our one-day assessment for you, and that's one of the things that we do with our logging equipment. Then you conduct a leak survey, identify your leaks. You incentivize employees to help you identify and report leaks as well. Maybe you give them a $10 bonus if they can, identify a hissing sound that they hear next to them and send it to their supervisor. And then you prioritize repairs based on, as I mentioned, cost and risk, right? Go for the big ones and then worry about the small ones if you have time. And then track savings, right? One way to track savings is to then come back in a year or two and remeasure what your leak load is, so you can see if you've met your target or whether you need to improve your cycle of repair, right? Detection and repair. So again, fairly simple to implement, very good payback periods, and very much low hanging fruit. Next slide. So one of the technologies you probably heard about now that's being utilized frequently in a manufacturing environment are variable frequency drives. Today, I'm just focusing on HVAC systems because HVAC systems are probably inherently the one variable system in the plant. There may be others that are associated with production, but because we're doing climate control and the outside environment is variable, VFDs are a very natural fit to HVAC systems. Now, we can certainly dive in to see if VFDs are appropriate for some of your production systems, but I'm pulling back right now to just focus on the one thing that most plants are going to have in common if they do any space heating and cooling. So for HVAC systems, VFDs are great because they adjust your pressures and flow rates and your fan speeds based on the outside conditions and the inside conditions that you're trying to achieve for the environment. They're great on energy efficiency because you're no longer having to stop and start equipment. You're basically adjusting or modulating those variables through speed control on the VFD drive. HVAC systems rarely operate at 100% capacity because they're sized for some of your hottest degree days or coolest degrees days. So other than, you know, a very hot day in July or a very cold day, you know, a couple weeks ago here, you know, your system is not operating at the capacity to handle those, you know, those extremes. They're operating in the middle, and that's particularly true in the fall and springtime. So payback periods for VFDs typically fall in the 1 to 3 year time frame, okay, which is why they're good. Now you see in that picture there, you'll see that little VFD drive. It says 60 hertz. That's just telling you it's a VFD drive. One thing I'll say is if your VFD drive and you have one installed and it always says 60 hertz, that's not a good thing because it means it's not varying and you're not getting any benefit out of the drive. In fact, you're actually losing energy because the drive itself has roughly a 1 to 2% energy loss associated with the inverter. So what you want to see is you want to see that number 60 hertz. You want to see that hertz vary, right, to the system that it's attached to and whatever is driving the speed control, whether it's temperature or pressure. Next slide. So here's some, again, things that we've recommended very commonly when we visit plants that involve VFD drives and HVAC systems. You can see we've recommended them for air-cooled chiller pumps, cooling tower fans, on the heating side, boiler feed water pumps, boiler forced draft fans. All you can see over there, the paybacks and the cost savings, you know, everything over there is, you know, less than 2.5 year payback. VFDs are typically cost about $200 per horsepower to install, but I will say TVA Energy Right does currently offer a rebate for those, which brings the price down closer to about $100 per horsepower installed. So, you know, take advantage of those rebates to do some of these retrofits if it makes sense. Next slide. Hello? Oh.
Is it not showing on your screen?
Yeah, I got it now. Sorry, must have been a lag. So the benefits of the VFD, right? I kind of mentioned some of these. Very precise temperature and pressure controls, humidity control, because instead of starting and stopping your fans, you have kind of a continuous airflow over your cooling coils, and you have much better control over your humidity, right, in terms of the evaporation process and how much is going to be lost to condensation. They also extend motor life. Starts and stops on motors are just not very good for motors, you know, so one of the solutions is soft starts. Well, VFDs can actually act as soft starts for you. So if it's a variable system, you don't need the soft start. You can use the VFD instead. So extending motor life is important, and they're easily integratable with a building automation system if you have one or you intend to purchase one. You'll also see in that picture that particular fan blower has a direct drive attached to it as instead of a belt drive. So we are trying to move technologies to direct drives because belt drives, of course, require more maintenance, and they also have associated energy losses with them due to slippage. Okay, so that kind of, those were my top 3 low-hanging fruits for you to consider, and certainly we can go into much more depth for higher hanging fruit. So, if you are interested, for example, interested in investigating solar, or something like that, we can do that. We can certainly take deep dives into some of your systems and get into more elaborate heat recovery type projects. But these are things that you could take back to your plant and probably implement yourselves without our help. Although we are happy to come in and help you identify whether these are, good choices to make for your particular system. And we can also help baseline some of your system energy costs. So my contact information is up there. If you're interested in assessment or you'd like to get more information, just drop me an email and we'll get back to you. So I really appreciate the opportunity to speak with everybody, and I'm happy to take some questions if there are any.
Yeah, I'm not seeing any, well, I have one in the chat box, but just a reminder, if you have questions for Dr. Machetta or us at TDEC, feel free to ask those in the chat box. Or if, you wanted, I guess, to, actually, here comes some. So I'm going to allow everybody to think about their questions, send those in the chat box. I've also got 2 sort of survey questions that I wanted to go ahead and ask before we get towards the end. So like I said, use that chat box, send your questions in there, but I'm going to have a short survey that we're going to have now. So everyone should see that. Crystal, are you able to see that on the side over there?
It is loading. Okay, yep, I can see it now.
Okay, so everyone should be able to see that on your right-hand side. And, this isn't going to hurt our feelings if you're not interested, but this just sort of helps us see, and also we understand if you've already had an energy assessment or you maybe don't fall into that category that Jeff was talking about at the beginning. That's fine, but we just are going to use this to, if you do say yes, might be able to reach out to you and see if it's a good fit for Jeff and his team or the people at Tennessee Tech to come over or just have initial meetings with you guys. So this is the first question. Are you interested in an ITAC assessment at your facility or want more information about it? And then I'm going to give everybody a couple more minutes. We've got 8 votes in here, but I think we have 20 people on. So allowing everybody to have the chance to vote on that. And then let's see.
Can I ask Jeff a question while in the meantime, before we go on to the next question? I didn't think about this till Caleb just mentioned it, Jeff. Do you do repeat assessments? So like, can a facility go back 10 years later, or if there's new personnel 5 years later that are maybe more likely to implement the measures that you recommend, do y'all do repeats?
We absolutely will do repeats. I think they require a 3-year time difference before we can come back and do the no cost assessment. I recommend it because depending on the plant, sometimes when we go in the first time, we are going to focus more on the low hanging fruit, right? And so, the second time, if you've never had an energy assessment, when we come back, we can then, if you've tackled a lot of the low hanging fruit, we do have the capability to do more in-depth kind of analysis. This is what I showed you today is I call that very basic assessment type of analysis, but we do have the capability to go into more depth. So I think repeat assessments are really good. And then we can also discuss challenges that the company may have had with implementing the recommendation the first time. So absolutely, three years is about the period where I can go back and get them to approve a repeat assessment.
And we just had a comment that said, I had an assessment by my alma mater, TTU, a few years ago, and it was an enlightening experience. I recommend them for everybody. So just, you know, just letting everybody know they're, you know, we're not just promoting it because it's, you know, the work that we do. Like, it is an experience that I think, even if you're not able to incorporate right off the bat any of the things in the report, I just think that it is just that, an enlightening experience, gets your brain sort of moving on opportunities that are in your facility. So if everybody has had the chance to vote, we have had about half the people vote on this. Are you interested in an ITAC assessment at your facility? If you're for some reason unable to vote, and you are interested, like Jeff mentioned, please reach out to him either through email or call, and you can also reach out to us as well, and we can connect you with either the folks at TTU, Tennessee Tech, or Jeff at the University of Memphis. Now, the last little survey question that I wanted to do, then we'll get into all of the attendees' questions. Let's go back here. Is based on the information learned from this webinar, do you see opportunities to implement changes in your facility? So this is just, you know, very high level, asking some of the main three things that Jeff talked about today. Do you see opportunities in your specific facility, your manufacturing facility, you know, wherever you work, to implement any of those? And this just sort of, once again, helps us see, you know, are we going over the right thing for our pollution prevention webinars? And once again, I'll hide the results so nobody can see what everybody's saying, and it's not going to hurt our feelings. This just helps us understand, you know, what the needs are of the manufacturing sector, the industries, and then, you know, if there's opportunities for energy efficiency projects. I think in my mind, you know, I'm not boots on the ground in these facilities, but I feel like the three things that you mentioned, Jeff, I mean, I think those are pretty easy. And I don't want to say easy because, you know, everybody's different, but in the grand scheme of energy efficiency projects, those are, you know, like you mentioned, low-hanging fruit are good starting points. So we've got a couple votes in. I'm going to allow this to keep going, but as we do that, I'm going to go ahead and ask some of the questions that we got for you. It says, how do you calculate approximate VFD savings?
Sure, good question. So it depends on the application of the VFD, but if we go to specifically to the HVAC systems, we use, you know, climate data, which gives us an assessment of the variation in outdoor climate conditions. We look at typical set points inside the plant. Based on those, there is a published set of ASHRAE loading estimates that we use for HVAC equipment. So when we look at a system that's start and stop, you're basically looking at you know, 100% load, although you can look at when it stopped and you can average that in as well to do that. But what we do is we compare a motor that is running at 100% load and then compare it to the motor that's at under the loading conditions that we expect for that HVAC system, which is pretty well known. You know, we can get down to the city location. So if you're in Jackson, Tennessee, you know, we have climate data for that. So, you know, it's pretty easy to estimate actually. Another way we can do it is to take measurements, although measurements you're only going to capture on one day when the variable conditions you're trying to model are year long. If we get into production type systems, what we most commonly see are valved piping systems or dampered fans. And anytime you have a valve or a damper, you're essentially creating an energy loss. That fan or pump is running at 100% and you're valving it to control the flow rate, which is understandable. You want to control the flow rate. Well, this is the situation where we would say, hey, you really want 70% of the flow rate of this system, and that's why you have the valve. So why don't we just put a VFD drive on there? Rather than necessarily buy a new pump or resize the pump, we can open that valve up to 100% and then just change the speed of the pump or fan.
Awesome. This is, I guess, a question for me. It says, will the slides be sent out to the team? I'll discuss with Jeff, but if he's okay with it, typically I will send out a PDF with a follow-up with the presentation on it. So just I'll make sure with you, Jeff, that there's nothing that shouldn't be shared. And if there is, we'll take that out. But other than that, be on the lookout by the end of the week for a follow-up email that will have the slides and the recording of the or a YouTube link for the recording of this webinar. So answers that question. It says, how do you calculate the leak rate percentage?
Yeah, that one's a good question. So the only way we can do that is if we're able to have the compressed air system running during a non-production period. So we have to measure the compressor power. We measure that during production, and then we measure that during a non-production period. And because the air compressor has a known power to CFM relationship, that's a performance characteristic, we can take the load and match that to the corresponding CFM for that load. So we compare the production period to the non-production period, and that's how we estimate the leak rate in the facility. So we can't do it if it's a 24/7, 360, degree plant, or day plant that runs all the time, 8760.
Awesome. And let's see one more. What do you think? What do you think of the use of pressure plates at workstations using compressed air? The pressure pads would allow for the airflow to the tools only when the worker is standing at his/her station.
I think it's a good idea if again the depends on what the use of the tool is. So if it's something that's used twice a day, that's very different from something that's used 1,000 times a day. You're not going to get a payback on a pressure pad if that tool is only used twice a day or even once an hour. So again, the implementation really depends on the frequency of use of that particular tool. But absolutely, in the right situation, it could absolutely work. We've looked at pressure pads. We talked about dust collection systems earlier. You can actually put a VFD on a dust collector system, and if you have stations that are all connected to a central dust collector, you can modulate the speed of the dust collector fan based on how much suction pressure you actually need in flow rate for each station. So if a station's not used, you basically would damper that station or have a cutout, and that cutout could be when the worker's not standing at the station. If you're worried about the worker turning the equipment off, I understand that's a legit worry. You don't need to rely on them, but that might be a good application for like a pressure pad.
All right, and one last question, that's all we got time for, is as an industry preparing for an ITAC assessment, what information and personnel should I be prepared to call upon during the assessment visit? Basically, how do we prepare for your visit to make the most of the assessment?
Sure. So as I said earlier, you're going to provide us with 12 months, one continuous year of utility bills. That hopefully isn't too hard to access. We do need the actual utility bills because we do take a deep dive into your utility bills. So we want to make sure you're not being overtaxed. We want to make sure if you're missing out on any opportunities for manufacturing tax credits. So we need the actual bills. That's gas, electricity, water, and sewer. And then we need you to complete the pre-questionnaire. It's roughly 3 pages. We just ask that you do the best you can. We're not asking you to commit 10 man hours or person hours to it, but we need a starting point for us to kind of strategize the assessment. So we do need the pre-questionnaire back, and then we need a plant map. On the day of the assessment, the people that we spend the most time with, probably honestly, are the maintenance engineers in the plant. They're the ones that are actually they're the most knowledgeable about their boiler or their compressed air system. So we need to be able to access them to perhaps ask specific questions. And then we need, if your plant requires that our teams be escorted around the plant, then we would need an escort for the teams. We typically divide up into 3 smaller teams during the assessment, so that we're out kind of doing parallel tasks. And so we need roughly 3 escorts to do those teams. We don't require escorts on our part. Our myself and my students are all have all taken plant safety training, and I always pair the students with a more experienced student that's already done 8 or 10 assessments. So but if you do require an escort, then we would need you to provide those so we can get around and get the information that we need while we're there.
Well, awesome. Thank you so much, Dr. Marchetta, for the work that you do. And I've actually been able to go on a handful of energy assessments, really, I guess more with the Tennessee Tech folks because I'm in Middle Tennessee. But any chance I get, I like to go just to learn from you guys and see y'all in action. It's really awesome. And I appreciate you, giving your expertise today and showing the low-hanging fruit, like you were mentioning, of the top 3 things that you see that maybe people can implement without even having to have an assessment. But like was mentioned before, follow-up for this webinar will be sent out later this week with slides and a recording link of the webinar. If you have any questions at all, please reach out to myself or Dr. Marchetta on with his contact information. Since you registered for this webinar, you will be sent our future pollution prevention webinar links as those come together. We've got 3 more planned for this year and an amazing in-person workshop that will be at Oak Ridge National Lab. So don't when you see information about that, and everyone on here will receive information and registration links for all those. It's going to be a little bit different than we're used to with our workshops, but it's going to be very exciting. I'm excited about it this year. So like I mentioned, as those registration links and all of that information comes together and things are confirmed, we will be sending that out to everybody that has registered and attended our resources and events. So thanks again, Jeff. Thanks for everybody for being here. Let us know if we can help you out in any way, and have a great rest of the day.